When we hear about the legendary kingdom of Kishkindha from the Ramayana, the standard depiction is a dense, simple jungle populated by the Vanaras. Surviving completely exposed on the surface during antiquity meant fighting a multi-front war, enduring volatile weather, lethal top-tier predators, and constant invading armies. The most effective architectural countermeasure to those threats is completely abandoning defensive walls and building straight down into the earth. Looking closely at the structural descriptions, the evidence points to Kishkindha as a highly advanced subterranean civilization that mastered natural engineering. Shifting our perspective from mythology to architecture reveals a calculated blueprint for a civilization where the landscape itself becomes the primary fortification. The surrounding mountainous topography functions as an absolute natural shield. The sheer rock faces and deep valleys completely mask any potential entrances from surface-level observers. Passing through those completely disguised surface entry points, the tight tunnels suddenly open out into a massive network of caverns. This split-screen chart tracks surface climates against subterranean ones. The top line fluctuates wildly, while the bottom line stays flat. Massive rock formations act as thermal mass, absorbing and slowly releasing heat to maintain a stable temperature all year. Instead of hollowing out the caves and destroying their structural integrity, the builders utilized what we can call Vanara architecture. They carved their giant structures directly into the natural geometry of the rock, seamlessly expanding into megacaverns. Pairing that geographical camouflage with perfectly stable natural thermals results in an impenetrable, passively defended front line. Surviving deep underground means solving two massive physiological hurdles: securing continuous water and generating light. This cross-section diagram illustrates the underground water management system. A primary aquifer at the top acts as the source, feeding fresh water downward through a precise network of gravity-fed, carved channels. To bring light into the upper and middle layers, engineers bored meticulous shafts through the rock, specifically angled to catch surface sunlight and magnify it deep into the earth. To illuminate the deepest reaches where sunlight couldn't penetrate, the builders cleverly cultivated specific strains of bioluminescent moss and crystals. These were managed to glow in predictable cycles, turning the walls into a living lighting grid. Mastering these underground aquifers and large-scale bioluminescence turned the void into a fully self-sustaining hidden biosphere. This technical illustration maps Kishkindha's macro-level layout, establishing a massive vertical scale from hidden surface entrances down to deep bedrock. Moving into the middle zones, dense residential communities intersect with terraced agriculture. To keep them habitable, passive ventilation ducts pull fresh air into the lower levels. At the very bottom of the structure sit the deep water reservoirs. These massive pools acted as the final catch basins for the city's downward-flowing water cycle. This multi-tiered, interconnected layout demonstrates that Kishkindha functioned as a singular, massive engineering machine. The underlying philosophy of this design is collaboration. Rather than conquering, clearing, and flattening nature to build, the architects worked directly with the existing geological formations. They achieved a perfect closed-loop system. Light, water, and biological life were balanced indefinitely without degrading the host environment. Compare that ancient subterranean harmony with modern urban planning, which relies on sprawling footprints that permanently alter the surface ecology. This vertical approach demonstrates that a civilization can scale to support a massive population while remaining effectively invisible to the world above. Whether viewed as pure mythology or a lost architectural reality, Kishkindha remains a significant example of how a society can integrate into the planet's existing systems rather than overriding them.